Stop. So now I'll explain the experiment because you're the one who's going to be doing the experiment. All right. So we have a bottle of water. All right. So it's got water in it. Should we put more water in it? Let's put more water in it. So make a bigger mess. So you tell the story.
So, my grandpa just made this up. He said he wanted to do an experiment because none of our experiments have been working yet. And he's saying if we put it in the water, it won't come out.
Now this could be a complete and utter disaster, or it could work well. So Nate, let's move that piece of ice to the side.
Well, actually.
So what you need to do, you need to pick it up like that and turn it over so that that goes underwater. Another way. So other way, yep.
Yeah, I know this one.
All right, so.
This way we put it on the.
All right, so it might be a bit messy, so let's quickly do it and go. And.
Success.
Success. So that bottle is not emptying. So even if we lift it up a bit, see actually how it's see how it's taken some of the water into it. So there we go, and it stops. So that's not going down anymore. So we have a successful experiment.
That's so cool. I thought that would actually work.
So what do we think is happening there? Why isn't that water coming out when we upend it?
Because it's down, and if it's in the water, it doesn't leak up because it's underground. So you can't put water underground.
So two things for me, I think, and I am not a scientist. Two things is that no air can get into here to displace. No air can get in here to displace the water, in other words, to increase that volume, because the column weight of this isn't enough to break the strength of the suction. Okay, if this column was probably higher, this column of water, it would be pressing down more and it might actually work. Now, I reckon that is a pretty reasonable explanation, but could be totally and utterly wrong. So there, the end of the experiment. Well done, Nate. High five.